Yeah, I don't know. I feel cold. So 221 and 222. Lots of dancing today because, you know, a couple tutus. Hey. So it is all dilation and similarity. I think I just killed Jake.
How is that?
I think I said it too fast. You maybe missed it. I said lots of dancing today because we had two tutus.
I got the joke. I'm just saying.
It's just bad. He's just like, it's just so bad. So today we're going to talk about dilations and similarity. And actually, I have an offer for you. We probably don't need to do both of these practices. So if you would like to pick 6 problems between the 221 and 222 homework, that can be our homework for today. Although I know some of you probably already did it because you probably don't have lots of assignments assigned to you yet from all of your classes.
I was supposed to do it, so I just ended up doing the whole thing.
Yeah, I mean, yesterday we said if we didn't get the test done, and then you could do 221, and we didn't get to the lesson. So we're not doing this because all my rubber bands are crappy and just breaking as soon as I pull on them, so I threw them away, and I need to order more.
Awesome.
But we could do this at some point. It's more fun if we do this with like a stick figure or something that's not a shape. But if we held a rubber band on the origin and had knots tying multiple rubber bands together, and you guys can try this, or if you find another 8th grade teacher who has rubber bands, we could do this.
Will you just make it simply like loop the rubber band to the end of the other rubber band?
Yes. So you make just a little chain, but then you have to keep the first knot on the image. So you stretch out here to get the first knot on the image, and then you draw keeping the first knot on the image. So I'm going to try to get rubber bands. I'm going to try to have us do this. But when I went to prep this, all my rubber bands got so old that they are just dried out and bad. So it's not going to work. So what makes similar polygons or not? So if we look at these sailboats here, Connor. Same angle measures, okay.
The curly sails. The sail, like, floppy thing.
What about it?
Like that it's coming over.
Okay.
And then the one that doesn't have that isn't similar.
Oh. So, you guys ever heard the one of these things is not like the other?
Yeah.
I think it's from Sesame Street. Probably. So, one of these things is not like the other. It has to have all the same pieces as the original. Now, when we compare, though, does this sailboat look the same size as this sailboat?
Yeah.
No, it's not the same.
They look different to me. Here, if we don't believe it, let's try this. Height of this boat from the top of the sail down to the waves. Whoops.
Silly.
I think it changed size when you brought it down. Because that silhouette's further in the background. So that was closer.
How do we know that, though?
Because it looks like it. 'Cause it's
So, I need you guys to decide, are all these polygons similar to each other, and how could we justify it if they look different? How could we justify it to someone learning similarity? So, as the question that I didn't get a chance to scroll past because I can't scroll any further, so you can think about a sequence of transformations.
Let me just get my protractor. Wait, do you have a protractor?
No. So, you can make if statements,
Why do you not have a protractor?
because protractors don't count on work like this.
Yeah.
Remember we said you can't physically measure the angle, we just have to go with what they tell us? So what is the if, though?
If,
Why are you asking for a protractor?
well, because we don't know the angles.
Why does that matter?
Because they have to be congruent.
Ooh, so if all 3 angles are congruent, and what else? All 5 or all 3, I guess. I'm mixing up A and B. What else, though? What would we need to be able to check if we numerically had things?
Oh, sizes have to like scale, right?
Ooh, so on a paper,
Scale factor.
I don't know why 2 of us don't have paper out, because we always need graph paper
I
out
have
in the math
paper.
classroom.
Right
Yeah,
here.
you have a whole stack of paper, right?
Yesterday. That's what the right word is.
Dilations. Is it D-I-A? L-A-T-I-O-N-S? Yeah, just DIL.
It's dilations, not dilation.
Dilations
For the longest time, I thought it was spelled that way.
/ similarity. So we said congruent angle measures, because we like using math words now.
Yay, math.
Math. Oh, math.
Why?
Why what?
I didn't have to make everything a program.
I don't think make everything a diagram. It's just something.
Because he was in 8th grade. Congruent angle measures, and then how could we say that formally, though? That whole, you're talking about this relationship in length. Man, I'm really hungry.
I just want those pancakes.
Why are you hungry?
Dude, I don't even get breakfast. Or is that your lunch today?
This is lunch.
I was about to say, if you're not taking advantage of free breakfast here, you guys
Actually, no,
totally should be.
pancakes are tomorrow.
You
Oh,
should
I don't
100%.
have time in the morning, though.
I would make time.
They have chocolate muffins.
I
They
can't
do?
make time. I ride the bus.
Just, yeah, when you get off the bus,
Last
go
year,
walk through there, grab
we went
food.
and tried to read
Eat real quick, and then come down here. There's no way that you're not getting here till like 7:35. Or is there?
Well,
Those donuts are
like,
good.
no, but
That was funny.
I have to be in class.
That's 7:40. I bet you could make time to eat. Alright, but what, so let's be mathy.
Okay.
The sides have to have what?
Scale.
A scale factor. So a scale factor relates every, crap, that word that means like
Relates
this.
corresponding sides.
So a scale factor relates corresponding sides.
You could be an actor because sometimes I don't know if you're actually not knowing if the word is what it is or if you're just acting. So
The secret is, I really don't know anything.
Whoa.
I just know how to ask questions. Alright, so what we're going to check is if we figure out which side should correspond with which side, do we have a consistent scale
Yes.
factor between them? And like we said, I forget what type of proof it is. There's that type of proof that if we can say this, then we know that.
choose column.
Well, yeah, it's one of those. But I think if we figure out this, doesn't that inherently make this true?
Oh, yeah.
So all we really need to do is prove the scale factor. Yeah, so it's essentially side, 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 just scale factor, side, side, side. Take some time with this. You guys are awesome.
They are similar.
How? You gotta justify.
See, you take triangle ACT and divide it by 2, and then you get triangle the other one. I don't want to.
Use a pencil. It's that.
Don't use a pencil on the smartboard.
No, but like those. I don't know what those are called.
No, use your eraser. It's like a pencil, but an eraser.
No, don't do that.
Actually, I think that mess up the smartboard.
Yeah, it would.
Well, get erasers on content at least. Why would you?
5 goes to, what is that? That's a gamma?
No, it's 10.
That's not a 0.
Yes, it is.
That's a 6. But backwards.
So, if then,
I did it.
if then, what's our relationship, or our order?
Oh, that means similar. Okay.
Dog
What's our
cat.
order? Dog, cat?
Dog, cat's what they want you
Dog,
to do.
at.
It's
ATC is actually a
it's
climbing
dog
device.
cat.
And ATC is short for an air traffic controller.
Wait, so we're starting with
It's
the D one?
It's DOG. Tiki CIT.
It's dog to cat.
Yes.
It's not God
No,
to cat.
wait. Are you real? Are you? Cause, wait. Isn't
No, I'm
it
sorry,
CT?
God and the cat brothers are congruent.
I think it's this one.
Wait a minute. Akshaya thinks it's that one. Uh-oh, those are different from each other.
Oh yeah, you're right. You're right.
But it sounds better as dog to cat.
I know, but that.
So wait, if it's dog to CTA, are any of the other ones? Because then I have a starting with OGD and a starting with DGO.
G.
No, because you're supposed to do the one that's that makes the most sense to remember.
D.
I agree.
This one works too.
Hey, my
That
circle
is
is so nice.
Ooh, DGO. So hold on, DGO goes middle side, then short side.
Yeah, that
So
was
CAT, does that go middle side, then short side? Wait,
Long side to short
CAT?
side. It's long side.
Oh, it is long side to short side, isn't it? DG. Wait, no.
Yes, it is.
D. Oh, because that one changed to DGO, not DOG. Ah, DGO is long side. And then III doesn't work either.
No.
OGD. What is OGD? Starts with
Oh.
5.
OGD is short side, then long side. ATC short side,
Middle side.
medium side. All right, so good identification there. We don't have to do that, but I know it's fun.
It's very fun. Yay!
It used to be even more fun when we had the physical eraser, like
Oh,
sponge thing.
yeah,
and
those
you
were
could, like,
so
press on
fun.
the board. I don't know, at least I thought.
And then they'd have to restart
And
it
that's the
and
lesson.
touch each
Oh,
of the dots.
calibrating it?
Yeah, that was
Oh,
the best
how-
part.
I do not miss calibrating the smart
That was
board.
fun, and then everyone would just come up and go bing, bing, bing.
Look, you guys don't even understand. There will be very soon a generation of kids that has no idea what you're talking about. When you say, you remember calibrating the smart board? And they're like, what? And do you guys remember why?
Because
Smart
like
boards
it
need to be
would be
calibrated?
too slow or something.
The projection
It
was
wouldn't sense.
There was a separate projector
Oh,
throwing
yeah.
the image, and this was just, all this was doing was picking up the image, or picking up the touch. So literally, like, you had to sync up the touch and the throw. Alright, so dilations. I don't care if you guys keep standing, it's only mildly awkward, but if you want to stand, that's fine.
Let me stand on.
Dilations lead us to similarity. That I'm not even supposed to do. Jake, I'm not even supposed to do that, so I probably shouldn't let you, because if you fall and bump your head, I'll get in trouble.
Then we'll say Mr. Hudson showed us that it's cool.
Yeah, and then I'll show the video and be like, look, defense. I told him to stop. So, dilation. Here is the confusing part. Dilation can happen in two different ways. We can either dilate from, well, actually three different ways, really. And this is me, like, off-book teaching. Here, we're actually doing two of the ways at once. We're dilating from the origin and from one of the points of the shape being used as the center of dilation. So actually, we probably should sit down and write this down, because you guys haven't done as much with this. So I would probably make like a caution, or like a beware, or like an alert sort of thing.
Cat eye on it. Got you?
Cat.
There's a science kind of stuff. Wow.
Make like a little,
Is that a nuclear power plant?
no, it's a little
It does look
alert.
like a nuclear power plant.
Whatever. So, the center
I'm gonna draw nuclear power.
of dilation could be, I don't like red. This is harsh for how bright this is today. The origin.
Oh wait, I just realized that the other day was 9, 10, 21.
Oh yeah, it was 9 plus. Okay.
Oh yeah!
I saw that on my TikTok.
21.
Yeah.
9 plus 10 plus 21.
You're stupid. Yeah, it's a whole thing.
Seriously, they
Oh, I know the whole thing. I just thought it died.
It
did,
did,
but
but then they just brought it back for
What
just
do you
9
mean?
one day.
9 plus 10 is a real thing. It does equal 19.
One of the vertices, or middle of the shape.
I feel like there's a third one. Or
Wait
fourth
a
one.
There might be. We can come back to this if we find out that there's a fourth.
Like any random point anywhere.
Ooh. Yeah, you're right. Any point. Sure, any point can be our center of dilation.
Wait, really? Connor was right?
I know. Surprising.
Oh,
It's
that's
almost
terrible.
like I was gonna ask the question, wait, does it matter?
That's dark.
Okay, Queen. Freddie Mercury, nothing really matters to me. So this dilates from the origin. So we say whatever the distance from the origin is compared to the new, whatever the distance from the origin is, take your prime point
Power plant. There we go.
over your original point, and that will tell us our scale factor.
C apostrophe divided by C.
Prime. Prime point.
Oh, prime C.
So let's practice this, because you don't have to have that written down. So,
Wow, the
Casey.
letters, wow.
Casey goes to the copy machine, she starts playing around, decides to set the zoom to 200%. Maybe we should go play with the copy machine someday.
Oh, yeah.
If she set the zoom to 50% versus 200%, how would that be different? Copier does not change in the angle measures, therefore the copier is dilating. So if our original,
That's not a C.
kind of a C,
It's like
Also, we don't know what the dimensions of the top point are. I guess that doesn't matter.
so when we go to determine our scale factor here, we take the prime value, the dilated value, over the original. Right? So what's our scale factor in what we're looking at here? 3. Or 1/3 if this was the original and that was the new one. Right? If we flip around which is the original, but original always goes on bottom. And if we compared 18 to 6, same story.
2.
3 still?
Yeah.
So, dilations create proportions, right? And this is why we're doing 2 lessons in one day. So, if you had a dilation where we didn't know the other value, what's the scale factor here? 9.
Yeah.
Isn't it 12? I feel like it's
6 times
Doc Shea feels like it's 12.
Yeah.
It is 12.
Yeah, you're right.
Ooh, we're right.
Yeah, 12.
I wouldn't
I
be right
thought
if
of
the 8 was on the
Oh,
bottom.
yeah.
So what would X be?
9
Yeah.
No.
Man, Akshay is just taking class today.
Wait.
Mean.
Ah, what?
Taking
What?
No, he's
She's like owning it.
Yeah, it's probably mean.
That's not a nice house.
Hey, don't call her average. That's insulting.
How is average insulted?
Well, mean.
Ugh.
Oh, wow.
Answer this question. I'll stop talking. Talk with each other.
Okay.
Wait, this is a theory. Wait, no, isn't there this thing where, like,
Are you thinking of side splitter?
yeah, I think so.
Oh. Are the 2 triangles so
That's a
Which-
much
which
better
2
variation.
triangles?
There we go.
A, B, C.
Yeah,
And A
variations
prime,
of
B
the
prime,
line
C
nuclear
prime.
power plant.
all of those 2 triangles? No.
Hey, so this is a real question.
I don't think
So, Rashida drew ABC.
Congratulations, Rashid.
Then dilated point A to create A, B prime, C prime. Which honestly, you could just say A also has a prime at the same spot. So wait, why are the 2 triangles? Oh wait, they're telling us they're similar. Why are they similar?
Because it was a dilation.
Because dilations make similarity.
Dilation.
So because they tell us that Rashida dilated, we know it will for sure be similar.
And we know the 2 lines are parallel.
And this is only that length. So what is actually AB?
AB is 10.
AB would actually be 10. And what would actually be AB
4.
prime? So what proportion would that create? What should we set?
5 over 2.
2.5.
Well, sure, that's an equivalent fraction, but we're looking at the shape we have.
Oh, 9.
So scale factor of 2.5, okay, so, wait, what?
Like, X plus 9 over.
Ooh, X plus 9.
So then we get to do those butterfly thingies.
over x.
Cross multiply?
10x equals 4x.
So, hold on. I don't disagree. The butterfly thingy cross multiply. Hold on. Is there any other way? So I get it. We could cross multiply. We've learned about cross multiplication years ago. But is 9 the new length?
No. But you can do x times 2.5 equals 9.
But is 9 the new length?
Oh, wait. No.
Well,
9 times 2.5 equals x.
But that's not right either. You're throwing out a bunch of wrong things, which is surprising.
Could you like multiply? That might help. You can do it. That might help.
No, the scale factor is
What's another way
2.5.
we could say... Hold on. What's another way we could say the new shape is 250% of the old shape without using 250? Or 2.5 or any version of 250.
So not like 2.5.
5 halves. 5
Hmm?
halves.
That's still the same number. You're not allowed to use that number, any form of that number.
The other shape is 1/5 of it.
1/5.
Or no, that's not right.
That's not right.
It's 1 2 over 5. So 1 2.5. It's a different number.
It is a different
Because
number.
we don't have the new length. Right, so essentially we should ignore the 10. Like, we have the new length 10, but we don't have the new length on the other side. What's another way you could say the new thing is 250%? What's the other way things get bigger?
They eat more food.
I mean, that's what I want to go do right now. What's the other way things get bigger? Guys, we're good at math, right?
Yeah,
How else can we get bigger?
Addition.
Addition.
Oh.
Now, hold on, like, hopefully you're thinking in your head like he's lost it, he's trying to add in a proportional situation. But is there any way you could talk about addition? And because, like, what we're saying is x and 9, right? Like, we have addition here, and we have 4 and 6. We have addition here. So from...
Can't you just solve it using proportion?
I mean, we could, but I'm trying to get you guys to think differently, and you're stretching out your math,
You
dude.
could multiply both sides by x and subtract 9 from both sides, and then you got what x equals. In a very strange calculation, but it is what x equals.
So here's our two triangles, right?
Actually, that's x.
Yeah.
With sides of 4 and x and sides of 10 and x plus 9.
What about if we find BC?
We can't.
Yeah, never mind.
Is there, I might even make it worth a lifesaver. Is there another way that we could say ABC is 250% of A, B prime, C prime, but not use 250%? How else could we say its size?
Well, we could say A prime, B prime, well, A, B prime, C prime, plus A, B prime, C prime, plus 1/2 of A, B prime, C prime, equals A, B, C.
So add another A, B, or add another A, C prime, and then add another half of
We
one?
could just say that A, B prime, C prime has a scale factor of 2.5 to A, B, C.
Yeah, but you're still using 2.5.
Yeah, it use scale factor.
You could say that this interesting question that doesn't have a practical application currently, because
All I'm trying to get you to say, and you're going to be mad, like, well, duh. Like, I think you're just probably, like, in one of those zones. The new dilated shape is 150% greater
Yeah.
than the original.
Okay.
Right? So hold on. Don't like discount me yet. So what we see is that the 6. You want to finish out what I'm going to say?
So then you have
6
to do
is 150% of 4.
x divided
9
9
is
divided by
150% of x. X equals 6.
Whoa.
It's
There's
math.
no cross multiplication needed. There's no complicated problem solving. The other way they want you to do it involves a freaking quadratic, guys.
What's a quadratic?
I know! Like, how are we supposed to use a quadratic
Is
if the
that
other
like
one...
the x equals opposite b or whatever?
It's like x squared plus something x plus something equals something. And then
Yeah,
we
it's
solve
like
it.
a over opposite b plus something all over 2a or whatever.
It's negative... yeah, well, I'll show you the video.
That just
It's your fault. Just by the way, it's your fault that you're gonna see the video this early in the year.
Oh, why
Are
did
you
you do
doing
that,
this later?
Jake?
Come on,
I didn't know
Jake.
there
I
was
didn't want to
video.
watch YouTube in that class. Come on, Jake.
Oh, dang.
Yeah, but once it gets stuck in your head, you might realize
Oh,
what
it's
I
a
mean.
song? Oh no, that's not good.
So
Haha, no.
we know that diagram 2. What's the question mark gonna be?
60
60. Because if we
Oh
dilate,
my
we're
No.
gonna
goodness.
stay the
That's
same.
it.
Who knew?
And that's that
Yay!
lesson.
Wow.
Now we have to
Wow.
watch the video.
Board game.
So.
I feel like it's homework time, Jake. But
Board games.
I also don't want to do homework.
I should teach you guys fugitive now that I brought it.